Good morning, ladies and gentlemen. We are going to finish up the families of the periodic table today. You will need two colors. One could even just be a regular old pencil that you use to shade in with if you haven't done that so far. And so you will, of course, also need your notes pages and your periodic table that you are coloring. Let's go ahead and get started. We're going to start with a little bit of review. We've talked about the fact that there are different ways to talk about the elements of the periodic table and different ways to group them. And we've talked about the fact that there are 7 periods in the periodic table. Those are the horizontal rows. There are 18 groups in the periodic table. Those are the vertical columns. And then another way that we can talk about the periodic table and its elements are to talk about its families. And so we've looked at 7 of the 9 families so far. We've looked at the alkali metals, the alkaline earth metals, the transition metals, the other metals, the metalloids, the non-metals, with the very nicely socially distancing hydrogen over on the left-hand side. We have the halogens, and today we're taking a look at starting with the noble gases. So they have them colored gray. You can use a regular pencil to kind of shade those in lightly if you like and haven't done that already. Go ahead and pause the video to color those in. Let's take a look at some facts about the noble gases. They're kind of interesting because of the naturally occurring elements, they're actually among some of the last ones to have been discovered. The reason for that is that they almost never react with any other element, and one of the ways that we know different elements exist is when we observe them reacting and turning into something else. They don't do that typically. Very rarely. There are just a couple of them that do. Another reason they were not discovered right away is because they are all odorless, colorless gases, and you can see that down below there. Now, the reason they don't react much with anything else is because their outer shells are full. Those outer energy levels of their electron cloud have the exact right number of electrons. They each have 2, helium has 2 because its outermost level is the first level, and so that level can only hold 2, it has 2. The others have 8 electrons in their outermost shell, which is what those outer shells need to be fully satisfied. And so with 8 electrons, they're not looking to gain any other electrons from another element. They're not looking to give away any electrons to another element. Because of that, they don't react. It's the action of either taking or giving electrons, that exchange of electrons, that is part of a chemical reaction. That's what causes the reaction. So they're very stable. They also, as we mentioned before, are gases that are odorless and colorless, and they also have a very low melting and boiling points, which is why in nature they occur as gases. All right, we're going to watch a couple of videos here. The first one, it's a really old video. It's a little bit blurry. It's a professor that's sitting up on the roof of a building, and he happens to have balloons that are filled with these different noble gases. And it's kind of interesting because he demonstrates how these noble gases, as you go down the column, as you go down group 18, the noble gases, they get more and more dense as you go. And so watch what happens as he releases the balloons. All right, let's see if we can get this video going. All right, here we go.
Here are 5 of the 6 noble gases: helium, neon, argon, krypton, and xenon. They're all colorless and transparent. Krypton and xenon form compounds only with difficulty. Helium, neon, and argon don't form compounds at all. As we descend the group in the periodic table, the atomic number and the relative atomic mass increases. The gases get denser. Helium is lighter than air. Neon is just lighter. Argon and krypton, I've just got to unstick these from the anchorage for a moment. Argon and krypton are both heavier than air. And xenon is the heaviest of the lot. You've heard of a lead balloon? Well, this is it.
I love that you can actually like hear the the landing of the balloon at the end because it is so dense and so heavy. So ladies and gentlemen, continuing on, we're going to watch another video that really focuses in on that last element that he mentioned there, the xenon. And again, he talked about its density. I think we've all at some point either heard somebody else or maybe done ourselves breathe in some helium and then start talking. And of course, your voice gets high and squeaky. With xenon, you know, it's just the opposite. The helium is less dense than air. It allows our vocal cords to vibrate very quickly, much more quickly than normal, which gives us that high-pitched sound. The xenon being much more dense, the molecules are packed tightly together and don't allow our vocal cords to vibrate very quickly, and so you'll see here what happens there.
Now, we've all seen that demonstration where somebody has taken a balloon of helium, breathes it in, and ends up speaking with a squeaky voice. If you haven't seen that demonstration, Google it now and come back. You back? Good. This is because helium is a gas that's less dense than the air that we breathe around us. If we had a balloon of it, it would float in the air. If we take it and breathe it in, it changes the resonant frequency of our vocal cords. So when we talk with a sound that's a higher pitch. Now, what would happen if we then got a gas that was denser than helium, denser than the air around us? In this balloon here, I have some xenon. Now, xenon's much denser than helium, but it's also denser than the air around us. So this balloon here will drop quite heavily. In fact, it feels strangely heavy. Now this is because xenon is much denser than helium. It's much denser than the things that make up the air around us. The things that are in the air around us are things like oxygen and nitrogen primarily, plus a few other gases. Xenon on the periodic table is way up this end where helium is. In fact, it's all in the same column over here. So this end of the periodic table, we've got all of these elements here. And right at the top, we've got helium. Xenon actually appears right down here, just about there. These are sometimes known as the noble gases. Noble because they're generally unreactive. Helium up here is the lightest of them. But as we head down here, these atoms get heavier and heavier until eventually down here at xenon, we've got something that's denser than the stuff that appears up above it. So if it's denser than helium, and it's denser than the air around us, and we breathe it in, it's going to change our resonant frequency of our vocal cords in a slightly different way.
So with xenon, we get a lowering of the voice. Scaramouche, Scaramouche, will you do the fandango?
All right, so I think we get the general idea there. I just wanted to point out to you, excuse me, I have something in my throat. But I wanted to point out to you for just a moment here that if you want to see some other fun, similar types of videos, although not actually having to do with noble gases, go ahead and in YouTube search for sulfur hexafluoride. It's another gas. It's not a noble gas. It's actually a gas that is a compound that's made up of both sulfur and fluoride. But it's a heavy gas, like xenon, and people have been known to breathe it in, and then again, their voice lowers, and there's just a lot of fun videos out there. It is something you have to be careful about, though. When you breathe that in, you're not breathing in oxygen, and you do need oxygen in order for your cells to survive. So it's not something that you would want to do a lot of. All right, so ladies and gentlemen, we're going to see if we can't go on to our next slide.
Can't get enough of your love, babe.
Okay, well, that's enough of that. All right, so ladies and gents, let's see. Here we go. So next up is the rare earth elements. This is our last family. They color it with light green. You may choose whatever color you wish that you have not used already. They are located down below the rest of the periodic table. Go ahead and pause to color. All right, some facts about the rare earth elements, also known as the rare earth metals. They are also known, they actually have quite a few names, come to think of it. They're also known as the lanthanide and actinide series. They are mostly synthetic or man-made. There are a couple of naturally occurring, but not many. They should be a part of group 3 on the periodic table. However, they don't really fit there very well. It's hard to fit that entire lanthanide series and actinide series. Lanthanides are on top, actinides are beneath. It's hard to fit those into the two little spaces we have for where they belong in group 3. Their characteristics match up with group 3, and so that's really where they should be. But they don't fit, so we put them below. They are all metals, and hopefully you have figured out by this time that most of the elements that make up our world, that make up our universe, that are listed on the periodic table are metals. You have your alkali metals, your alkaline earth metals, your transition metals, your other metals, and then you also have the rare earth elements. All of these are metals, which means about 3/4 or 75% of the elements that we know of are metals. All right, I'm actually going to ask you, after we finish this video, there's a second video on my blog in this lesson, and it is about the rare earth elements. I'm going to ask you to take a look at that. There is some language in there that I don't love, but there's also some really good information. One of the things that they talk about is just how critical rare earth elements are to our electronics. We would not be able to have the laptops and phones and things that we have now without these rare earth elements. The other problem, though, with rare earth elements, we love them because of that, but the problem with them is most of them are radioactive. And so what do we do with the waste products from using these elements? And they talk a little bit about the fact that China has been willing for many years now to kind of deal with that issue and to take care of it. Maybe sometimes they aren't taking care of it in the best way possible, but then we're not taking care of it at all, really. So you know, as a country, we are starting to think about the fact that we probably should deal with this situation ourselves, but it's definitely a problem. It's definitely an issue, because as with most things in the world, there are positives and there are negatives, and there definitely are some really big positives to the rare earth elements and the things we can do with them. There are also some really big negatives, and something that we as a human race need to figure out how we're going to deal with. So ladies and gentlemen, make sure you take a look at that video. We are at the end of the families of the periodic table. Hopefully you have your whole periodic table filled in by now, as well as your notes. If you do not, please go back on my blog and look back through the entries and see if you can find the video you are missing. If not, let me know. I do think there may be one video that is missing from that series, so if you would let me know if you can't find it, and I will either make it if I haven't made it, or just send you the link. Thanks, guys. Bye.